Hello, everyone, and welcome to another episode of CppChat. I think we're going to have fun today. I want to welcome back Matt Calabrese. Matt has been with us before and is back to share some thoughts about C++. Good morning, Matt.
Morning.
And how are you doing?
I'm doing all right. Doing all right.
Okay. And I also want to welcome the first time Robert Ramey. Robert, you want to talk a little bit about what you do and tell us about, particularly tell us about the Boost Incubator?
Okay, I've been actively involved in Boost for, well, gosh, since I guess 2003, so that's a long time. I'm the author of the Boost serialization library, and I'm also constantly making suggestions, if that's the right term, for improving like the Boost infrastructure. I made a lot of suggestions about a year ago, 2 years ago. One in particular, I was very dissatisfied with the review facilities and the quality and the encouragement given to people who wanted to develop for Boost. And on that basis, I created the Boost Library Incubator with the hope of helping out people, make the job simpler. And having had a wealth of experience on making the Boost serialization library, I found that there was a lot of stuff that, had I known then what I know now, I could have saved the amount of work probably by a factor of 2. So I consolidated that all into the Boost Library Incubator. I would say it's been a very modest success. I think there's 30 some odd submissions, maybe it's a little more. 5, I think off the top of my head, 4 or 5 of those have been successfully accepted as Boost libraries. So frankly, I think that's pretty good. I think that like only 10 or 15% of libraries which people think would be Boost quality are in fact Boost quality according to the consensus. So the percentage is okay. I'm kind of disappointed. I would have liked to have seen more submissions. But you know, at least I think we have. Yeah, I leveraged on the Boost way of doing the review. I think that's the absolute heart and soul of Boost. I didn't want to mess with that. I just wanted to make it easier to do and provide some infrastructure for it. So it's been a modest success. I'd say the serialization library was a bigger success, but you know, at least it hasn't been a total failure. And
I think that's that's understanding. It's really great. The incubator is great. I wouldn't undersell it. So.
Well, I think not being a total failure, frankly, is pretty good given my whole life experience. So you know, it's just a question of defining success down to the point where you can meet it. So, in any case, that's that. Now I'm working on. That's actually pretty much where it's going to be. If I do get an opportunity to fix it or improve it, I do it if it's not too hard. I learned a lot about the whole way the whole web infrastructure thing works. It's like agony for a C++ programmer. It connects me with the younger generation, which is not appealing to me at all. It's just so anyway, now I'm falling back on, I'm embarking on something which has bugged me for like 40 years of dealing with crappy code, some of which I've created myself, and I'm ramping up on that. I'm writing a book on abstract algebra and its connection with C++ and program provability and things like that. So I've been somewhat encouraged by the success of Stepanov's books. Mm-hmm. And I'm giving a talk on the progress of that work at the C++ Con. I hope more people sign up than did for the last one, which was a total of 5. So you know, but I'm always optimistic for no particular reason. So anyway, that's what occupies my time now.
Well, I certainly can sympathize with your adventures. // CppChat, which is the URL for for this show. I am embarrassed to say how long it took me to put a simple countdown timer on there. That's all I wanted. I wanted to have something where you could go and it would tell you how long it is to the next. And between WordPress, actually, the JavaScript stuff was straightforward because I'd already done something like this for the 2 conferences. So the JavaScript stuff was not the hard part. The hard part was that WordPress just does not like you to have arbitrary JavaScript running in it, and so you have to jump through a whole bunch of hoops to make that possible. It would actually have been easier to put it on the sidebar, but I didn't want it on the sidebar. I wanted part of the main. So yeah, I completely sympathize. WordPress has sucked up more of my life than I would like to think. Anyway, but no, I think the incubator is great, and I think I think Boost. I wasn't really planning to get into the whole Boost thing, but I think Boost is kind of in an interesting situation now. It's a victim of its own success because Boost was kind of defined initially as, this is a stepping stone for things to get into the standard library. And now some of the most valuable stuff in Boost is now in the standard library. And so people don't look at Boost with the same delight that they used to. I mean, it used to be, it's like, oh, wow, smart pointers here, there's just all this cool stuff. And we're now, because of our success, those are now, I mean, one person told me, said, well, Boost used to be all the libraries that you wish were in the standard, and now it's all the libraries that aren't good enough to be in the standard. Something of an exaggeration.
I wouldn't say that. We have Boost serialization. We have Boost serialization.
I'm just quoting, and I think even the person who I was quoting was intentionally exaggerating. But you can see how it's done that. And the other dimension about what's going on in Boost, and I know this is something Robert has pointed out and made very clear to me, is that when Boost first came along, which was when the standard was first published, right? I mean, so that's a long time ago, '98. That's when Boost first came along, and at that time, the idea of distributing a library was a non-trivial way of doing it. I mean, how do you do updates? How do you communicate with people? And so what Boost did was gave a potential library author a platform, whereas today you go on GitHub, you send out some tweets, and you're done. Okay, it's a bit of an exaggeration, but you don't need Boost the way we used to. And in fact, I think if you look at what Eric Niebler did with the Ranges library, right? I mean, Eric is very involved with Boost. I think he cares very much about it. Well, he's on the Boost steering committee. I think he cares a lot about Boost, and he's part of the community. But when he did his library, I talked to him about it. And he said, well, the Ranges library was going to be challenging enough, and I just didn't think I needed to go through those extra hoops of going through the Boost process. And it was because he could leverage GitHub and a blog, and so as
it's interesting because that's something I actually sort of disagree with Eric about. I actually think that it would have been really great if he had gone through the Boost process. Now, I'm a member of the Boost community and the steering committee, so maybe I'm biased, but I think people undervalue the importance of the review process that happens, because it is very easy to go on GitHub now and just pull down libraries, but what you miss out is the review process, which is sort of invisible to a lot of people. Like people who just only download a Boost release, they don't see the fact that review even takes place. They don't know about it. And I'm a little bit worried with people directly proposing things to the standard or just putting things up on GitHub without getting the type of people looking at it and criticizing it in the Boost community that used to be a much higher bar to entry to getting a library kind of in use. And I think Boost, it would be beneficial if more libraries kind of went through Boost still. And so I think we're missing out. But
I would go much farther. I think that libraries such as ASIO, the Boost serialization library, the Ranges library, a Units library, these are gigantic efforts.
Yeah.
And the standard library process was, to me, sort of built around the idea that standard library includes specifications for components that each vendor will implement himself. And that's why the standard language doesn't describe these components in terms of implementation, but rather required operations to support and things like that. So now, to me, you can take any example, even ranges or serialization. Now, if somebody specifies that and it gets into the standard library, are vendors now required to implement that from scratch? I don't see that happening. I mean, it's just a huge project, and I'm guessing that. And I noticed the math function toolkit has been included in the standard. I know that they're just incorporating the source code, which actually happens to be in Boost, and maybe cleaning it up a little bit. So that, to me, kind of means that the whole concept of the standard library as originally conceived has already been set aside, and now the standard library is more of, well, just a library that one incorporates. But I think that, how should I say that, the effort to get something like ranges or ASIO, I think it's just immense, and I just don't think that the vendors can be expected to do that. And so now they're although it may not be a Boost library, but who's gonna maintain that afterwards? Eric has done an incredible amount of work, and still that amount of work hasn't covered the creation of a user manual. I'm not faulting him for that. I'm just saying that the mechanism we have doesn't address what we need today. Yeah. So I think the idea of coupling these large packages as standard library components to the vendor's responsibilities is frankly not realistic, and I think it's going to hold us back, and I think it is holding us back. So I think we should just we should forget the idea of expanding the standard library except for tiny components, and we should really think about a different mechanism, which would be basically Boost on steroids.
That's an interesting approach. I hadn't really thought about that. I mean, we just kind of take it for granted that the standard library is going to be there for us, and it doesn't really matter. You know, once we standardize something, of course, there will be multiple implementations of it of high quality, and that is asking an awful lot. Right?
Oh, well, let me put it this way: who's going to implement ASIO in the standard library? Who's going to maintain that? The vendor's going to do that? I don't know.
Well, I imagine the vendor's going to do it, and like you said, with like the math, with the math special functions and everything, one of the reasons it was accepted was because there was a very high quality Boost implementation with a very permissive license, which the vendors are going to pull in, and especially in the case of ASIO, I'm sure that Chris Koloff is going to have his open source implementation that would be in line with whatever we get for the end specification. And
well, that's absolutely true, and that's exactly points. I think that supports my view that the standard library isn't a specification anymore. It's a version of Boost, if you will.
I don't know if I'd go that far.
Well, but they can't be responsible. They actually, even with the comments on the math toolkit, they said it was rejected, but now that they found the actual implementation, reviewed it, they decided that now they could accept it. So I go in a whole different direction here. What I would like to see this CAR Hoare, who's a well-known person in 2005, suggested a grand challenge project, and that would associate with a set of verified software because, well, the provability kind of didn't work out for him. But the whole concept of having some group of code that can be drawn upon, which is known to be correct and vetted, it was proposed by him, a person of very high prestige, and yet, of course, since he spent all his time in the university, he thought in terms of some sort of weird supported project that didn't have anything to do with business. I go a totally different direction on that too, but which is a different subject. But I really think the concept of decoupling the standard library, especially let's call it facilities, from the standard library itself would be something to really consider. It would mean that libraries that are not worth maintaining anymore could more easily be deprecated. It would mean that new libraries could come in. The scheduling would be decoupled from the compiler releases. It would be faster to get something like Rages in because it would basically be able to go in as soon as it was really proved to be ready. So I think that the whole concept since 1995, when they brought in the Stepanov's library, I understand why it was done at the time, but I think it set us off to a path where we've arrived today, which is going to start holding us back.
Well, I think right now the situation we're in is even if we wanted to do that, I think we're at a point where it's still, unfortunately, in the year 2016, it's still really difficult to pull down libraries, pull down dependencies, and like if you're working with multiple different projects, if it's not part of the standard, you're going to have multiple different versions of the same library, and this is like an unsolved problem in C++, unfortunately, even though, again, we're in the year 2016.
Yeah, but if we had buy-in to this idea, and frankly, this is the first I've thought about it. I mean, I always thought, okay, we'll get things into the standard library, and then once they're in the standard library, magic happens, right? It's like step 3, profit, right? Because I hadn't really thought about the fact that this is, two of these libraries are open source and one is proprietary, but none of these organizations have infinite resources, and these libraries are non-trivial. And even if you look at the library and you say, okay, well, we have ASIO and it's baked, it's good, it's fine. Everybody just takes a copy of the Boost repository. Well, there are going to be hardware issues. There are going to be all sorts of things over time that this library is going to have to continue to be maintained. And a library like that is, that's not an easy library to maintain. It's going to be a lot of work, and maybe it does make more sense for these resources to be pooled. And I think the solution to the problem you just brought up, Matt, is it would certainly be possible. In fact, I'd love to see it if the standard library vendors would take a snapshot of Boost and say, by the way, here's your implementation, here's your compiler, here's your standard library, here's your Boost library, and then whatever implementation you use, then yeah, they might have a newer version you want or an older version you want, but they've provided just like they provide the standard library, and it would actually kind of make a better separation of concern. I mean, they would still work closely to make sure that version of Boost works with their library and on their hardware or whatever their release is.
The separation of concern thing is key in my view, because we're coupling the language and the library issues when we do this, when we have the one standard, so that the issue of dependency is the vendor provides something, but now you're depending on something which is all mixed together. If I knew that the Boost serialization library worked on any conforming C++ compiler, that's what I should be looking at. But if I'm a vendor, I don't care. I make whatever changes, so they're automatically forking the library with the changes that they make in order to make it work with their code. So I think that I don't think we see that very much, but I think that's a problem. But the original success of C was that it was delivered as a simple compiler plus a library, and it factored everything it could, all the I/O, etc., into the library, so that it was easy, so that the originators of C didn't have to really worry about the library so much. They could keep their jobs small. I think we lost that because C++ is not small, and that's one of the reasons.
Yeah.
Okay, I kind of beat that to death. Huh? I got carried away.
Ben Dean in chat is saying part of the problem here is also the lack of ABI compatibility, and yeah, that's completely true.
Well, I think that's a feature of the C++ compilation model. That is a conundrum that we're not even close to addressing that. So he's right, and that's of course why we have to distribute source code, and that's why that in fact, in practical terms, it doesn't create the problem that we think it might. I'm not seeing that on my IRC, but it doesn't matter. Anyway, so I think I kind of overdid that subject, but
well, actually, I think quite the opposite. I'm ready to move on, but I think in the future there's probably an awful lot we should talk about Boost
Well, I can actually I can touch upon another facet of that, which I've assiduously avoided to keep the thing from getting totally off the rails.
Yeah.
But if you want to discuss a little more along these lines, I got something else in my bag. But if you could pick something else,
well,
I don't want to.
let's talk a little bit about kind of news right now. By news, I mean things that happened in the last week. And of course, I always think first of CppCast. They had an interview with Stephen Kelly. I'm not sure if it's Stephen, probably Stephen Kelly, and he had an interesting. Well, it's not. I don't think shipping yet, although I think you might be able to download it and play with it. But he's making CMake into a server so that IDEs can query it for things like CMake completion. So you can do type-ahead completion for when you're editing a CMake file. And some of the other stuff that I just thought it was kind of interesting. Are you a CMake guru, Robert?
No, not at all, though I know more than most people about it. And it's due to just necessity. I got a lot of opinions about it. I got a lot of opinions about people who think they know a lot about it. It's it's just it's not bad. They're after it. It's got weaknesses. The main important thing, they got good support for it. The document is really problematic. It's harder to learn than it should be, but on the other hand, can be made to work. I mean, it's kind of like a lot of stuff these days. I'm not really happy with it. Oh, by the way, the Boost build thing. I'm probably the longest running continuous complainer about Boost build in the whole world. I have a great respect for the Boost developers because they really hung in there. They support their concept and they work at it. They do the job. It's not really appreciated as much as it should be. That doesn't prevent me from being really critical of that. And I think that we should, in Boost, spend more effort to move in the direction of CMake.
Yeah, I don't know very much about Boost Build or CMake. I was just talking to Matt. Yeah, I was talking to Matt earlier that I've always been on a team where someone else was in charge of figuring out those things, and so I've always loved that. So I'm not an expert on it, but it does appear to me, just as an observer, that CMake has won, and I'm not certain that it won on technical merits, but it doesn't really matter. CMake has won, and I think that Boost has to recognize. When Boost started out, CMake wasn't there or wasn't the clear winner, and I think Boost Build made a lot of sense in its time. And I still think, I've been told that technically it's very good. I've also been told by people who have worked with it that don't care for it, but I think that's going to be, I've heard that about every build system. So I think that that Boost needs to recognize that CMake has won, and we want to be part of the rest of the industry, obviously. That's very important to us. And so we've got to figure out how to be CMake friendly.
No argument here, although I do recognize that it's easier said than done because Boost Build does have stuff that is not available anywhere else. So that's a big issue.
And that's basically my stance on it right now. And like John was saying, I'm personally not a huge build system person or anything. And so I don't know what type of effort would be involved in switching over to CMake, and from my understanding, there are lots of things that would be very difficult. There's a lot of great things that Boost Build can do, and it would be an effort, and somebody has to be doing that process. But if it turns out to be something that somebody's willing to put the time into, I think it's reasonable that we would be able to move forward towards a CMake-based Boost. But
well, I look at it a somewhat different way. My proposal when I had the I think 2 years ago or a year ago, I guess in 2015 at CppCon, was, hey, let's not think about we're going to change to CMake. Let's just alter that. Let's decouple the Boost libraries from any particular build system and let each library developer support whichever one he thinks is best for his job. So at that point, Boost would become more build system agnostic, and less. Boost would be driven from the bottom up, which it has been in coding. We would recognize that that's the way that Boost functions, and permit library contributors to support either build system or a build system of their choice, and then the promoters of Boost Build would basically have to compete for the library developer audience. So that to me would be the transition, that we would not have a monolithic system anymore. We would just have a little bit more open and tolerant system as far as choosing the build system. Just like we do with the documentation, by the way.
I feel like it's a little bit harder to do that with just the libraries individually. I mean, documentation I think is a little bit separate because you don't have things like interdependencies between the different libraries. I think we should be able to say, like, this is, you know, the build system that the project is using. I think that it being monolithic is something of a benefit, but I don't know.
Well, I think non-monolithic is kind of inevitable at some point. I think it almost has to be. You know, there's a point at which it just doesn't scale. People should be able to pick and choose. We're not going to solve that right now.
Well, yeah. I mean, people should be able to pick and choose, and there should be able to be interdependencies. But what I mean is, when you pull down like the Boost library, you shouldn't have to be like, well, in order to work with this library, I have to, you know, use this build system, or, you know.
Well, yeah. The way Robert described it, I think, sounds chaotic, because you'd say, wait a minute, I want to use a particular build system. I don't want to have to use 3 different ones because one library supported to this. But in practice, it wouldn't work that way. In practice, what would happen is I submit my library, and I don't know anything about CMake, so I just made it work with Boost Build. But there's a group of people who are passionate about CMake because that's what their company does, or for whatever reason. And when they see a new library, they say, John, this is what you have to do so that we can give you CMake support. And I say, oh, okay, well, I can do that. And you know, I think what would happen in practice is that there would be both Boost Build and CMake support for the entire Boost library, and there would be a team of people who, I mean, it wouldn't be hard to get Boost Build support, obviously, because of where we're starting from. But what would happen is there'd be a team of people who would contact each library author if they needed to do anything. I mean, it's quite possible that most of the libraries, all you need is the CMake, what do they call it, script, or whatever they build build
what
list.
you see is people contributing and submitting PRs that include CMake support, and that would be the end of it.
Right.
That's already been happening.
Right. And ideally, I think it should be set up in such a way that this. Well, I guess the problem here with CMake, this is one of the things that's touched on, is that CMake is kind of intrusive, at least in the sense that it expects files to be in a certain place, right? My understanding is that's not a requirement, but that's kind of the protocol. That's what everybody does, and so it does require that the author accept the file as part of their library, but it doesn't really require that they know anything about it, right? I mean, a CMake file could be created, and then we just put it at the root of the library or something like that.
Well, the contentious discussion that we had a couple of months ago or weeks ago or whatever was that in order to really support CMake in the manner that it was intended, you have to sprinkle a few files into our sacred Boost directory structure. And you know, it was one of those discussions which kind of ended up turning on kind of almost ridiculous points, because that's the way our discussions do. And so, you know, to me, if somebody wants to support CMake and they put their files there, that's fine. If Boost wants to say it has to support Boost Build, that's okay, but I'm thinking in the future we should relax that requirement. As far as dependencies are concerned, that's not a problem really solved by Boost Build or CMake or any other situation as well. So I don't think I even have to worry too much about that. And I just think that we just have to accept the fact that if a user is not going to be able to import all of Boost in the way he has in the past as it gets bigger.
Well, anyway, so I appreciate this discussion, and I appreciate it a lot. But I wanted to talk about, I guess we started talking about Stephen Kelly's interview and it ended up back on Boost because it touched on CMake. The other news from CppCast is that they're going to be dark for a couple of weeks. I don't know if you call it dark when it's an audio podcast. I guess they're going to be silent for a couple of weeks. So that That's disappointing for me because I look forward to that every week. But maybe I talked to Jason. Maybe we'll get Jason on as a guest, or Rob, and let them talk. Speaking of Jason, the other big announcement was the plenaries. Did anybody see that announcement?
I did, and I was curious about. Well, I thought I was intrigued how the decisions were made about what's a plenary discussion and which isn't. I mean, that's actually not a criticism, and I think that Jason's snippets on C++ actually are really good, and I think really helpful for a lot of people, and I think he's done a great job with it. The whole thing about how speakers or papers are chosen is a little bit murky to me. So anyway, but I did notice. I for one noticed that.
So that's a little bit by design. The process is, the overall of the process is pretty clear. Sometimes you don't really want to know how the sausage is made. The regular program, I think you guys are both familiar with. We have a call for submissions. People submit. The program committee goes through and ranks each of the submissions, kind of in an abstract on its own, without thinking about, and people on the program committee are explicitly told, if there's lots and lots of talks about a subject, don't consider that. Evaluate each submission on its own. And if you see, oh wow, there's 3 talks or 4 talks. I think this year we had 4 talks on random. I don't know where that came from, but we got a bunch of talks on random.
Yeah, there you go. It's random.
Yeah, it's random.
It's just variance.
It's just variance. Yeah. And they all looked good to me. I mean, they all looked good to me. And I think we took, I can't remember if we took 2 or 3 of them even, which is probably more than we should have taken. But they were all good. Anyway, the program committee is responsible for evaluating each talk on its own without thinking about how does this fit into the overall scheme. But then the program chairs, and we have 2 program chairs. Actually, we kind of have 3 because I think Bryce is going to be now a program chair. But the truth is, the program chairs don't really do it on its own. There's kind of an internal committee of about 5 people, and we all look at the ranking. That's kind of the starting point. It's kind of like, let's just assume the ranking. Okay, now let's look at the ones we're accepting. Is there too much duplication? And then let's look at the ones that we're not accepting. Is there a particular reason why the committee overlooked a gem? And there's certainly situations where that's the case. And the example I give is a particular speaker who the first time he submitted a CppCon was just, his submission was rated very, very low. But there were people on the program chairs who had actually worked with him and had seen him speak at C++ Now and said, no, we got to have this guy, even though he was rated low. And so he was given a spot, and I feel like we were really vindicated because when I did the surveys, which we do every year, I looked at the surveys and we look at each speaker's rating. He had the highest rating of any speaker. He didn't have a very big crowd. It was kind of a niche talk, but everybody who was there was impressed with his talk. And so that's why I understand it's a little, I don't know what to say properly, it's maybe undemocratic to say, well, here's the program committee, they looked at it, they evaluated it, and now the program chair is allowed to ignore it. But the program chair is allowed to ignore it. The program committee does a lot of work, and it's taken very seriously. It's never ignored whimsically. It's the basis, it's their starting point. But we look for holes. We will say, wait a minute, we don't have a single talk on X this year? How did that happen? And then we'll seek somebody out who we think could do a talk and say, could you talk on this? And so so that's how it works. Some talks from fairly good speakers, we say it's too close to this other talk or something like that, and we don't accept it. And then on the other hand, talks that are not highly rated, that we think either the subject matter is important or we think for some other reason we really want to see this talk, that happens. So that's happened. And then as far as how do keynotes get selected, that's one way they get selected is that we look at regular submissions and we look at it and say, that looks really interesting. we would make it a keynote, and that's where Mark Maoni, I can't remember how to pronounce his last name, but he's the Mars rover guy who would give a keynote the first year, and he just submitted that as a regular talk, and we looked at that and said, that's really interesting, and we would like to have that as a keynote. And so that's one way that happens. Another way that keynotes happen are that we try to reach out to certain industries, and certainly that's where Mike Acton, who is recognized in the game industry, we looked for a keynote that we thought would be interesting there, and the fact that he hates C++ made for a really interesting talk. So
I actually thought that was a really great talk, even though he was very negative about C++. So.
Absolutely. I mean,
yeah.
we don't have room for somebody who just comes in and screams about C++, and there's a lot of that on the internet. That's not a problem. We want somebody who has constructive things to say, and I think he did. He wasn't screaming C++ just because he hates C++. There were specific issues he had because the kind of code he wants to write doesn't map well to C++, and that there deserves to be a talk there. And he has a reputation in the game community. We really, really, as I said, I see CppCon as a platform for the entire C++ community to talk. But I also, my vision of the C++ community is that there's a lot of mainstream C++, but there's also these islands that are separated. And I think of the game industry as one of those islands. They don't talk enough with the rest of us. We don't talk enough with them.
That's improving, though, which is really great. Yeah.
I think it is, and I'm willing to take credit for that. But I don't mean me personally, but I mean CppCon. I think selecting Mike Acton, working hard to recruit game speakers, and also what Michael Wong has done, creating SG14 and actually meeting at CppCon.
And also at GDC, didn't they meet at GDC or something one year?
Yes, yes. I think, and so I think we have done, like I say, when I say we, I mean the community has done a great job of building a bridge between the game developer community and mainstream C++. We see that in the standards level. We see that at the conference. And as I said, I'm willing to take credit for that. I mean, it's a lot of it's Michael, but I think some of the credit we earned, and it was conscious decision. It wasn't just, oh, look, this keynote we picked, it's working out. No, we went for that. That was what we looked for. This year, David Schwartz is a result of us consciously trying to find someone who could help us reach out to the financial engineering community, because I think that's a really important community. And as much as the game developer community is an island, the financial people are even more of an island. There are fewer names that are recognized. I was talking to a particular company who the conference has a relationship with, and the CEO of their company, they were talking about he might attending himself. And that got my wheels turning, and I thought about it. I said, well, maybe here's the guy who's the CEO of a financial engineering company who is a programmer. I don't think he's really strong in C++, but he's a programmer. Maybe he would be a good keynote. And when I contacted them, they said, well, it turns out his schedule's changed. He's not coming, but our CTO could come. And the interesting thing is that in the email, they didn't even mention his name. And I couldn't figure out who he was. I had to go back and say, well, who is your CTO? And would anybody outside your company know him? And it's not that he's not a great guy. It's that part of what we wanted was, a reputation. We wanted people in the industry to know. The problem is there's almost nobody. The financial engineering community is really closed. They don't want their people, in the game community, people talk about their games and the work they've done, and they're proud of it, and they develop a reputation. But in the financial engineering community, nobody talks about their successes. And they're very, very closed-mouthed. And it's really hard to get people to talk because they're afraid they're going to accidentally blurt out some algorithm that their competitors will use. I don't know.
Secret,
So it's really, really hard. But David Schwartz, Ripple's in a little bit different situation. They're not trying to do high-frequency trading, but they are doing financial engineering stuff. And I think that the blockchain is a fascinating topic. So I think that was a good fit. I'm not sure how well it's going to work for reaching out to the financial engineering community, but that's what we're trying to do. We're trying to bring that community in. So that's part of what we look for. So I don't know how much that answered your question, Robert. We consider an awful lot of factors in figuring out who's going to be the plenary. It probably, I think we kind of start with the assumption that Bjarne is going to do a keynote, and I think we've kind of at this point started with the assumption that he's going to do the Monday keynote. He didn't do the first year, but I think that's probably what we're going to do. It wouldn't have to be that, but that kind of gives us a starting point to work from. And Bryce has mentioned, he says, nobody outside of you and I pay any attention to this, but we actually differentiate between a keynote and a plenary. And he says, nobody pays any attention to that, John. They just think they're all keynotes. And it's like, okay. But there really isn't any difference anyway. We label one a keynote, we label one a plenary, and that's we tend to say that my distinction is I think of speakers as either in the family or out of the family. In other words, people like Bjarne and Herb and Chandler and Eric Niebler, people who you expect to see at a C++ conference, they're in the family. They I'm happy to have them. All those guys are great. They give great talks. They're audience favorites. Well, I also want to have people who I consider outside the family, and David Schwartz is an outside the family. He knows C++. He's a C++ guy. He could easily be he could be attendee, but you don't really see him at C++ Now or CppCon, and so I consider him outside the family. And that's what we want to get a mix up. I want both, and we will probably tend to make the outside the family people keynotes and the inside the family people plenaries, but that's not a hard rule. I think we'll try to do 2 to 3 keynotes. I don't think we're going to have 5 keynotes. We'll just do 2 to 3 keynotes. But as I said, it doesn't really matter. That's just a label. It seems important to me. I don't think it's important to anybody else.
Yeah, go ahead.
Anyway,
I was just going to let loose with something that was probably not a good idea.
Oh, okay.
Okay. I'm a little sensitive these days.
And this year we kind of have a theme of embedded. So Dan Sachs is embedded, and also Jason's talk is really an embedded talk. I don't think we're even using that name to describe it, but that's really what it is. It's showing how you can use C++ in a really, really restricted environment. And I think a Commodore 64 is about as restricted an environment as someone can imagine in 2016, right? So with Dan's class and with some of the other embedded talks and with an embedded keynote, which is Dan's keynote, and an embedded plenary, which is Jason's plenary, I think we're doing. I'm trying to reach out to that part of the industry as well. So that's the thinking on keynotes, plenaries, and I think what we have not announced, which I'm kind of surprised because Bryce is working on this and is going to moderate the closing panel, and I think he has all his ducks in a row to make that announcement, but he didn't make it, so maybe he just wants to make it as a separate announcement. But the Friday afternoon panel, I think, is going to be a lot of fun, and I'm looking forward to that. So what else do we want to talk about? Oh, I wanted to talk about turning Egyptian division into logarithms. Do you want to talk about that, Robert? I noticed you commented on that blog post.
Well, the reason I commented on it because of what I've been working on has actually required me to investigate that in quite a bit more detail than was described there. So I just happened to know that he made an assertion that was flat out wrong. Well, I mean, it happens, you know. And then he came back and said, actually, he got that from Stepanov's book. And so we had a little thing on that. It just turns out that that particular algorithm is necessary as just part of the code base that I'm using to support this book. And basically, it's the addition of any. It implements addition for any additive semigroup, and those things go beyond just mere numbers and other things. So things can be added even though they're not numbers if things are defined properly, if you use that algorithm which doesn't presume the existence of numbers. So it's a very kind of arcane point. It's, I think, very uninteresting to most C++ programmers. On the other hand, I hope to make a small contribution to changing that, and so that's how I happen to be involved in that. I can't really say much more other than I just want to flog my talk, and I hope more people. I hope more people show up. I hope to create a little interest and intrigue about it. But you know, hey, I have a mixed bag on that, so we'll see how that works out.
Okay.
What I do believe is that there's a much more stronger application and connection between abstract algebra, program provability, and also programming from a practical standpoint that are made without knowledge of these things end up to be programs a lot harder to maintain, have a lot more bugs, take longer to write, etc., etc., etc. So I'm trying to make this stuff seem applicable in a practical way. That's kind of the nutshell what I hope to accomplish. And okay. If not, you know, hopefully it'll be entertaining. You know, I like to think I'm an entertaining speaker, but you know, not everybody believes that either.
I've seen you speak. I'm always up for it. I think, and I'm also very interested in generic programming, getting this stuff right. Did anybody see the latest? Sounds Ben Dean just said that his talk about standard accumulate draws heavily from abstract algebra, although I try to highlight a practical approach. I think that's one of the problems that people get when they start talking about generic programming at this level is that it seems like you're splitting hairs and it's not really practical. Well, but I don't think that's the case. I think once you understand it.
No, you set me off. You know, generic programming is just like a random bag of tricks. And then it turns into competition. It's turned into a competition. See who can make the most arcane and most tricky and complicated thing, and your degree of success is directly proportional to the number of people who can't understand it. So that's a problem. And you mentioned to me once that Alex Stepanoff didn't like Boost and thought it went off in the wrong direction. I'm thinking that's kind of what he might have been referring to, and I believe that all those criticisms are correct, and I believe it's because they've been added on as a cool trick after a cool trick layered on top of another couple cool tricks, instead of having a fundamental conceptual basis in which to place all these things. So
I think you've got exactly what his criticism was. He's not interested in just what cool meta tricks you can play with C++. Mm-hmm. That was never his intent. You know, Alex is a mathematician first, and I remember him being on a panel once where he said something like, you know, the only real languages to think about are C and C++ because they are the only ones that model the machine the way it actually is. All the other languages have some, have some kind of, you know, abstract machine that isn't exactly the way the machine works, and so
they're incorrect abstractions. They're like, what are you? Yeah. What's an abstraction over if you're just making up a machine underneath? Right. You know.
Well, now if you touch on that, you know, I got a whole nother rap.
Well, so, but he's just to finish the thought. The reason I was saying this is it sounds like he's a real C++ fanboy, but in truth, he could care less about C++. C++ right. was just the best tool for him to.
It's a vehicle, not a destination.
Exactly, and you know, one of the things he told me, he pointed out in one of his talks, and I actually use this in my exception safety talk, is that.
Wait, who's he in this?
Alex Stepanoff.
Okay, so you were actually talking to Alex. Okay.
Yeah, Well, it was nice because we worked at the same company, so I've had a lot
You
of
worked across the hall from him?
He was actually almost straight. I was on the how did that work? I was on the second floor. He was on the third floor, something like that. I think that's how it worked.
So you were actually above him in the company?
No, below. No, absolutely below. But anyway, he told me. He said, this original implementation, it was the vector assignment operator or something like that. It's not exception safe, and I talk about it in my talk because I point out that he was showing this library to the experts in C++ at the time, and it took 6 years for somebody to point out and say, that's not really exception safe. And the way I do this is I show the code in my class or in the lecture I'm giving, and I ask people what the problem is, and it usually takes less than 30 seconds for somebody to point out and say, well, this code's not exception safe, and I make the point. I say, initially it took 6 years for the biggest brains in C++ to figure out this is not exception safe, but we now, as an industry, it takes, a room full of C++ programmers can figure that out in 60 seconds. So, we've made a lot of progress about understanding exceptions, and so I think it's a tractable problem. So that's the point I make. But the point Alex made when he was talking about this, he said, well, yeah, he said, but I didn't actually write this code. He said, this is when he was working at Bell Labs, and he needed to have an assignment operator, and he said, how do I write this? And one of the C++ experts said, this is how to write it. And we would not consider it good writing today, but they wanted to leverage, don't repeat yourself. So they leveraged the constructor and the destructor. So what they did was they destructed it in place, and then copy constructed it from the copy. And that way, they didn't have to, the assignment operator has a lot of code in common, or potentially in common with the constructor. And
so that sounds like it was before the copy swap idiom, or now the copy move idiom.
Well, because nobody was thinking at the time about exception safety, right?
Right.
So anyway, the point is that whenever he had a C++ question, in fact, I know this because he would sometimes call me. And he would say, I'm trying to get this to work, and Bjarne's not in his office. because Alex basically had a straight line to Bjarne. Anytime he ran into a problem, he would call Bjarne and say, Bjarne, this isn't working, and Bjarne would work on it with him. And when Bjarne wasn't around, he called me. I could be flattered, except it was just a practical matter. But anyway, it was Alex did not consider himself a C++ guru, and did not think that the direction that C++ was taking us, what kind of clever things can we do with metaprogramming, was the right direction. I think, and I remember there's a panel from C++ and Beyond where Herb and Scott and Alex, and Andre, and of course Andre has done more to advance, template metaprogramming, craziness than anybody, and all of them were sitting there basically telling people not to use it. It's too crazy. It's too pushing the edge. It's too, But I think somebody had to do it because that is why the standard supports this stuff now. You don't have to be quite as crazy. There are still some crazy tricks. But if you look at something like Hana, which depends on 14, you can't even do Hana in 11. It's now really easy to read and easy to understand, at least certainly easier than the tricks that we had to pull back in '98, right?
Mm-hmm. So I have a little bit of a different view of metaprogramming in that, I think most people's criticisms of metaprogramming are just because it seems arcane. I think that's just an artifact of our language just not being a good vessel for expressing compile time metaprogramming. We've gotten a little bit better with things like constexpr, and Boost.Hana helps it a lot, like you were saying, but I think that's the main issue with metaprogramming. I don't know about Alex's specific criticisms of it, but I'm going to speak in defense of metaprogramming here and just say that, it solves all the same problems that we do at runtime, and it's just, we unfortunately have to do it in a slightly different way, but I think if that weren't the case, there wouldn't be such a negative view of it.
Yeah, it's the syntax which is a killer. It's like the tax code, So it's the concept actually is, unfortunately,
it's very simple.
The syntax doesn't do justice to the concept, and that's created a lot of issues. of course, it does create an opportunity for creating a lot of problems, but then all programming does. So, but the main problem is this, especially before, the syntax was just sucked your brain out, through a straw.
Especially because it was, well, it used to be purely functional, and so coming from C++ as an imperative language, a lot of people just look at this, and I mean, getting past the fact that you have all these angle brackets, which is already, you have to think, you have to think in a functional way, which a lot of people weren't familiar with. But again, now with constexpr, that's changed a little bit, and we can do a little bit more in that manner. And now people don't think it's quite as bad, and it's primarily because the syntax and because we can do it, imperatively.
Right. Well, and some of the things that used to be this kind of weird Boost thing are now in the standard. And things like enable if, which it used to be that was this Boost hack, and now, oh no, that's just part of the language.
No, that's a library hack. Huh?
I still consider it a hack, even though it's in standard library. But
yeah.
Well, it's a hack you need right now. So
exactly. I call it a hack, but I use it every day. So.
Yeah.
And I want to put in a plug for. I just watched it again because. Louis Dion, who is the author of Hana, gave a talk at C++ Now. He gave a couple of talks. One was called Metaprogramming for Experts or Geniuses, and the other
was for the brave.
For the brave, yeah.
Yeah.
And the other one was Metaprogramming for Dummies. And he just gave the Metaprogramming for Dummies again at our local group in Mountain View. And so I got a chance to see it again. Yeah, well, and you missed out. It was good. And of course, it was pretty much the same thing, but it really is amazing because his whole point of the talk is, he says the way we've taught metaprogramming is wrong in that you had to understand all this bizarre syntax before, but now because of 17 and because of Hana and what the library is doing for you, he says you can really think like a runtime programmer and just push some of the stuff into. And he does. It's kind of amazing how few angle brackets he was using. Leveraging, of course, tuple, although Hana has its own tuple, which is better for compile time performance, I think is basically the difference. It works very much like the standard. In fact, that was one of the questions that came out, was, well, what's the difference between your tuple and the standard tuple? And he says, well, there are some constructors that I don't support, and the reason is they don't have good compile time performance, so I just have my own.
Yeah, part of the problem with standard tuple is now, I think with 17, I'm hearing an echo. I don't know if somebody, did we lose?
I'm hearing an echo too, but I don't think it's me.
Okay, I don't know. But anyway, I'll keep talking. One of the problems with std tuple is, there's something like 30 constructors now in 17. You actually have to implement it with something like 30 constructors. And what people don't realize is these things have, we're using things like enable if and stuff in the template parameter lists, and so even when you call one specific one of these constructors, overload resolution has to take place, which means each one of these definitions has to be considered, which means that depending on how the template's written, you have a certain amount of other templates being instantiated simply by considering those other constructors. So by just having this, we're seeing impacts in compile time that you wouldn't expect, even though you're only using one constructor. You have to go through substitution of the other ones. Yeah. But I'm hoping stuff like that will change now that we touched on this a couple weeks ago, I think, or a few weeks ago. I'm hoping that the fact that now we have the Richard Smith's proposal, the guaranteed copy and move elision. I'm hoping that we'll move away from having 30 different constructors that are publicly visible to instead having named functions, and it doesn't enforce any other requirements on the types now because we have guaranteed move and copy elision. But we'd be able to avoid these problems where you have 30 different ways to construct a type, you better have 30 constructors, and they all have to be considered, and you have to have ways to disambiguate between the different ones. I don't know. Sorry, I went off on a tangent a little bit, but I hope
that's what we do here.
Yes, that is. It's great. Unfortunately, we've kind of hit our. I try to keep it at about an hour, and so we're there. I hate to cut it off because it's a great point you just made, but it just means that we've got so much more to talk about next weekend. Now, next weekend is going to be a little different. I'm going to be traveling, so we're going to shift and do the talk on Sunday evening instead of a morning talk, which would make Bryce very happy. I don't know if he's going to be able to join us, but anyway, I'm hoping to get Matt Bentley, who is in New Zealand, and so he can't really very easily join us at our normal time, but if we can do one in the evening, perhaps he can join us then. But anyway, it's been great. We obviously have a lot. I always think, well, has anything happened this week that we can talk about? Turns out there's things that are, there's issues out there that we need to talk about, whether they happened this week or not. So I appreciate everybody joining us. I want to thank everybody in the chat room for their comments as well. And send us an email if you have a question you want to bring up or a topic you want to talk about. Otherwise, thanks very much, Matt, and thank you, Robert. I appreciate both of you guys.
Mm-hmm. Awesome.
And to everyone, we say safe coding.
Safe coding.
Thanks.